So the first one we have is f of x equals x minus 12, and the next equation is g of x equals the absolute value of x. And we have to find the domain, the domain of f, g, f plus g, f minus g, yeah. Oof.
Well, what's
So
the domain of, we'll start with f of x. What's the domain of f of x?
What is it? Is it 12?
Remember what domain is. Domain is what possible values from the number line can you plug in for x? That's what domain means. Well,
okay.
There's no restrictions. I'm not dividing by x. If I was dividing by x, I wouldn't be able to plug 0 in. I'm not taking the square root of x. If I was taking the square root of x, I wouldn't be able to plug in negative numbers. So every function has a different domain. But the way to think about domain is, what can x not be? What's the domain of x?
So it's just all real numbers.
Okay. Now, what were the ones they wanted?
G. So we need to find the domain of f, g, f plus g. So f plus g would still just be, or g would still just be real numbers, wouldn't it?
Yeah, in other words, it's a strange thing to be asking about domain, because so far none of these domains have been restricted.
Yeah.
So that's f plus g, and again, there's nothing that prevents you from plugging in any value for x. F minus g, same thing. This question doesn't make much sense.
Doesn't?
No. Usually if they're asking you about domain, it's restricted in some sense. In other words, if I said f of x was 1 over x minus 1, what is the domain of that?
Just real numbers?
No. There's one value of x that does not work.
One value of x that does not work? Would it just be another 1 or 2?
Not 2, but 1. In other words, there's only one rule restriction here. You cannot divide by 0. If you remember one rule in math that's at the top of everybody's list, that you cannot divide by 0. So whenever you get division by a variable, you got to make sure that that denominator is not 0. Well, the only thing that makes it 0 is an x of 1.
X of 1, okay.
Yeah, because then you'd have 1 divided by 0. That's not allowed. You can't even do that mathematically. That's what domain is all about, is what values can you put in for x? And it generally is about what values can you not put in for x. In other words, most of the answers are all real numbers. This answer would be all real numbers except x equal 1. That would be the only restriction on the domain. Your problem, it doesn't matter how we put them together. I can't see how we're ever going to have a restriction. We did f plus g and f minus g. What else?
Oh, that was it for that one. Hold on.
Yeah, no, I mean, I understand their purpose for asking these things, but that problem is not a good illustration of anything. If you want to get somebody to understand about domain, then give them something where the domain is restricted. And what they're trying to point out in that problem, probably, is that it's possible for the domain of the combination to be different than the domain of each function. this one doesn't point it out because this domain is not restricted, either one of them. But sometimes they can be restricted, and when you do like f of g, you end up having to sometimes carry those restrictions forward, even though it's not obvious that they should be. So there's a legitimate question about domains and composite functions, but that sure didn't illustrate it.
Okay. Let me get to the next one real quick.
Okay.
Just a sec. So this one is solve and graph the solution set. And it's it's 8 minus 7y is less than or equal to 14y minus 3.
Okay.
Okay.
Is that it?
Yes.
Okay. So there's only one variable here. So the graphing of the solution set is going to be done on a number line. Okay?
Okay.
If there are two variables, then the graph would be done on an XY coordinate plane. And you really would have to graph it in order to solve it. Feels to me like there should be another equation here also. But nonetheless, let's solve that for y. How do you do it?
Do we put the y's on one side?
Uh-huh.
Okay, so would we add 7 to the right side and
Yeah.
add 3 to the left?
Yep, that works. That way, remember that I only have to worry about the direction of that thing when I'm multiplying or dividing by a negative number. In this case, I'm not.
Okay.
I added 7y. Even if I subtracted 7y, would not have been multiplying or dividing. Okay, so the solution is what?
It's 11. Wait, no, would we divide by 11 on both sides?
No.
So it's 11 over 21 equals,
Divide
or
by
is
21.
less than 1.
Divide by 21 on both sides, not 11.
Oh, okay.
In other words,
So
always remember, you're trying to isolate the variable. Wow, this happened early on me and I had to reboot. What is going on with my drawing tablet? Wow. I can give it a temporary fix here and see if this works. Let me try it. Otherwise, I'm going to have to reboot and send you a new meeting ID number. Hold on. Let's see if I can get this thing to work. Huh? Beautiful.
did it work?
Uh-huh.
Okay.
Now, let's make sure it works on this program. I proved that my drawing tablet worked, but I haven't gotten it to work on this program yet. Yep. Okay. So, if we're graphing that, where do we start? I'll put 0 on there. What point do I need to put on there?
11 over 21.
Okay, we'll call that point right there. Is that
Okay.
an open dot or a closed dot?
What does that mean?
Well, you
I've
use
never
an
heard of
open
that.
dot if it's just greater than or less than. You use a closed dot if it's greater than or equal or less than or equal. So that's the difference.
Well,
This is open dot because
okay.
y is greater than. It's not greater than or equal. If there was a bar under that, then it would be a closed dot. Now, I'm not done. I got to draw the graph of this. Which way do I go? To the right or to the left?
To the right.
And there you go. And then you put an arrow on it indicating it goes all the way to infinity. And that's the solution set. If I had to write it in interval notation, it would be 11/21 to infinity, parentheses around both.
Okay.
Okay.
Let me see if this works. By the way, we're getting your money in too.
Okay.
That's coming. Yeah, that should, from what I'm told, that should be in by the end of the day.
Okay. Thank you.
Hold on. It's just like, so the way they want this entered in the website is completely weird and doesn't make any sense.
Here, let me make you the presenter. Let me have a look.
Oh, that won't do anything. I'm on my phone right now. With the see, because what I do is I watch you work out the problems, and as you're working them out, like I enter it on my computer. It's a lot easier than like if I do both on my phone, if that makes sense.
Not sure I totally understand, but whatever makes the most sense to you to learn it is what you should do.
Yeah.
However, I don't know what you're referring to with what it's doing right now. I have no idea what the problem is.
Yeah. Well, it says the solution. It says the solution set is like, yeah, but there's no way to enter it correctly the way he wants it. I think this site's bugging. I don't know. Let's go to the next one. I have.
Let me. Let's just make sure it's not something like this.
Okay.
If I said, give me the solution set to that, notice I have two variables. Well, the first thing I'm going to do is graph that linear straight line. I'm going to start at 3. I'm going to go up 2 over 1 to the right. I'm going to connect that with a dotted line. Now, which way am I, above or below that line?
You're going to be above it, aren't you?
And now they say also y has to be greater than 0. Well, I think that doesn't narrow it down anymore. And x has to be greater than 0. That does narrow it down. Now my solution set is strictly from there all the way to infinity, but that is the combined solution set for these three equations, or rather these three inequalities. Now, if you have multiple inequalities, in this case, the only two that I really needed were those two and those two. Let's cross that one out because that doesn't add anything to the problem. But if I have two inequalities and they say, what is the solution set? There's really only one way to present it, and that's graphically. There's no way to algebraically say what the solution set here is, other than these two statements. In other words, I could say the solution set is that and that. But most people, that's not what they're going to ask you. They're going to ask you for the solution set graphically. And when I do that, this is the only way to show it. I have no way of describing that. How am I going to describe that? I have a triangle that goes to infinity up top, and it's got bounded by, in other words, it would be very, very difficult to explain that area without showing it. And when you started to give me the last problem, I was sure that that's what it was going to be, was two areas, you had to figure out what the combined region is. But it wasn't. It was a single dimension thing that you graph on a number line. So anytime you just have X or Y alone, your graph is going to be on the number line. If you have both, then your graph is going to be two-dimensional, not one-dimensional.
Okay.
All right, what else?
Before we go again, do I have any appointments scheduled for like Wednesday and beyond, or is it just today and tomorrow?
Just today and tomorrow.
Okay, I just wanted to make sure. I don't want to like, I have someone coming over for Wednesday through the rest of Thanksgiving, and also I don't want to do sessions with you on Thanksgiving. You know, that kind of takes away your time.
Yeah, no, I've got Thanksgiving blocked off anyway. I'm going to be out of town on Thanksgiving. So, but
Really?
yeah, I'm going down to the Springs. I got family down there.
That sounds kind of fun.
Yeah, actually, it's supposed to be a nice day. It wouldn't be fun if it was snowing, but it's supposed to be a nice day.
No.
So I'm looking forward to it. And it's kind of nice to have a Thanksgiving week. Basically going to be off, other than your session tomorrow. I'm going to be off for the rest of the week.
Yeah, that sounds good.
Busy I've been lately. That is a welcome vacation.
I bet you've been super swamped with all that work.
I have been. It's gonna be worse come the next 2 weeks after Thanksgiving, because that's the 2 weeks that leads up to semester finals.
Oh yeah.
And I do want to ask you that don't make appointments unless you plan on keeping them during that time period.
I won't.
And if you're only going to plan on doing a half hour, just schedule a half hour rather than always scheduling an hour.
Sure thing.
Just because I fully expect to be fully booked. And so if you schedule an appointment and don't take it, it basically locks somebody else out that could have taken it.
Okay, makes sense.
All right. So what else are we going to do today here?
Let me look. I'm just trying to see if there's anything we can work on.
Mm-hmm.
That's like super important. Hold on.
Do you always do these sessions on your phone, or do sometimes you do them on a laptop?
I have the My Math Lab website on the desktop.
Uh-huh.
And then I have.
You don't notice any difference doing them on your laptop as opposed to doing it on your phone?
Not really. It's kind of just the same either way.
I wouldn't be able to do it my end on the phone just because it's not a big enough writing area. But I suppose on your end might not be that big a difference because it's mainly audio and you're always looking when I'm drawing. You're not actually drawing on your end, so.
That's pretty much it. It's pretty simple.
Mm-hmm. Now, is the app that you use a Join GoToMeeting app or is it a GoToMeeting app?
It's a GoToMeeting app.
Really? It's not specially named Join GoToMeeting?
Yeah.
Huh.
So I could organize my own meeting on that app if I wanted to.
Well, yes and no. You got to pay $49 a month to host GoToMeetings.
Yeah, but
Now they do give you the first month for free, so they might let you do it. But I have to pay $49 a month to be able to host an unlimited number of meetings during the month.
Okay.
And so I've always assumed there's two different programs, that there must be a GoToMeeting program and a Join GoToMeeting program, but it doesn't sound like it from what you're telling me.
It might be. I don't know. I could be wrong. But who knows? Okay. For this next one, it's a determine the order of the matrix. and the matrix goes, parentheses, -4, -7, -9, 6, 6, -8.
Hold on. First of all, you got to tell me, if we're talking matrices, are you going across or are you going down?
I'm going across.
Okay, so what's the first row read?
On the first row, it's -4, -7, -9.
Okay.
And then on the bottom row, it's 6, 6, -8.
And there's only 2 rows?
Yeah.
It's the rows by the columns. So this is a 2 by 3. And that's not a variable x, that's 2 by 3. Okay. If I had 3 rows and 2 columns, it would be a 3 by 2.
So that's a 2 by 3?
This is a 2 by 3. You start with the rows. The first number is the rows, that's the columns.
Okay.
Now, if you had, one way I can help you memorize it is if you've had matrix multiplication. Yes or no?
A little bit.
If you are multiplying this by another matrix, the only way you can do it is if the middle number is the same. In other words, if I want to multiply it by another matrix, it has to be 3 by something. I could do 3 by 4. I could do 3 by 2. But these two numbers have to be the same. Otherwise, you cannot multiply the two matrices.
Okay.
And the way multiplication is done, let's multiply it by 3 by 2. In other words, if I have that, okay, this one is a 2 by 3. This one is a 3 by 2. Because the middle numbers are the same, I can multiply it. How do I multiply it? I take that whole first column, lift it up, rotate it 90 degrees left, and place it over the top of the first row, and multiply it together. So I'm putting the 2 there, I'm putting the 4 there, and I'm putting the -1 there. Now I'm going to multiply that to get -8. That one becomes -28. That one becomes +9. Add those 3 numbers together, and you get your first cell in your answer. In other words, you get that cell right there. That is matrix multiplication. Now, the only reason I talked about it is because when you're trying to figure out the order of a matrix, it's easy to get, you forget, if you haven't worked with it for a while, it's easy to forget which comes first, rows or columns. In other words, is a 2 by 3 2 rows by 3 columns, or is it 2 columns by 3 rows? And by understanding matrix multiplication, you can always figure it out. In other words, when I first told you about it, I was only about 95% sure. And so what I did to convince myself was to multiply it by a 3 by 2. I know that that's possible. As long as that number is the same as that number, then you can multiply it together. Notice I would not be able to multiply it by a 2 by 3. I've got to have the number of rows of the second matrix equal the number of columns of the first matrix in order to be able to multiply it together. That number, incidentally, was -36 minus 27 is what goes right there. And then I get each cell from doing the same thing. Next, I'm going to take that column and place it on top of the second row and do the same process. That'll give me that cell. And I'm going to take that column, place it on top of the first row. That'll give me that cell, and finally that cell. And I end up with a 2 by 2. When you have a 2 by 3 multiplied by a 3 by 2, you get the outside numbers. You get 2 by 2.
Okay, that makes sense.
Is that the only thing they wanted to know about that particular matrix, was what was its order?
Yeah.
And I think that's what they mean. I'm not even 100% sure they mean 2 by 3. I can't figure out what else that would mean. That's not the determinant. There is the determinant of a matrix, which is much more complicated to figure out. But the order is pretty straightforward. The order is the number of rows by the number of columns, I think.
Well, that was correct.
Okay.
So the next one is write an augmented matrix for the following system of equations.
Go ahead.
And it's negative 3x plus 5y equals 3. And then the next one is 8x minus 3y equals 6. So this is the first time I'm seeing this. I don't know what I'm doing really.
Well, this is pretty hard stuff, but I can show you how to write the augmented matrix. The augmented matrix is the coefficients with another line and the answers.
Okay.
There's the augmented matrix. Now, solving it is the issue. In other words, the great power of matrices is to be able to solve lots of equations with lots of variables. You've had to solve 2 equations with 2 variables many times. And we could do that. We could use one of those 2 techniques to solve this. You've occasionally had to solve 3 variables with 3 equations. And you've seen that that is about 4 times harder. Well, as the number of variables increase, it gets increasingly more and more difficult to do it manually or to do it in the traditional way with substitution and elimination. So in real life, you sometimes might have 11 variables and 11 equations. And so if you're going to put a computer on that task, because if you did it by hand, it would take you, 47 days. So if you put a computer on that task, it's going to use matrices. And augmented matrices in particular are good ways to solve a system of equations. Now, the technique that is used to solve this system of equations using an augmented matrix is quite complicated. I can do it, but I'm going to have to look it up in the book and just do an example from the book and explain it to you. You can also do it on a calculator. And most people do that. In other words, but you have to input it in a certain way, and I'd have to look that up also. I get augmented matrices about once every 2 years from students. And I have 50 students a year. And only about every 2 years does somebody bring up augmented matrices. So it's not that common. But you obviously have had it presented to you.
Couple.
What would you like to do as far as today goes? If you want, I'll look it up and we can go into this. I think it's liable to take more than 13 minutes, though.
It would be better if we just do that tomorrow.
Okay, let's do that. We'll make that the
That's
topic of the day tomorrow.
Okay, that's good.
Okay. Now, I would ask tomorrow that if you're going to be late, please text me in advance because
Okay.
you don't understand. I got to come up and sit in front of my computer. And when I get up here at 2 o'clock and you don't show up till 2:15, I'm twiddling my thumbs.
Okay.
Okay. So I don't care. I don't care if you're late, especially on days like tomorrow where I don't have anybody else. But just let me know. That's all I ask.
I will.
All right. Okay, Merrick. I'll talk to you tomorrow.
I see it.
Bye-bye.